here actually give a little bit of explanation. You can look at this part. So we have actually done something similar in the ARP part, which is actually that too. So one of two, the code is actually pretty simple. We can spoof ourselves as NIOS. So later we can actually use the attacker machine to actually sign up. Alright. So if you use the attacker machine to sign up, you will see that your IP address is NIOS. And you are typing, alright, you are typing NIO5. You use ICMP.
I don't see any like sequence error, etc. today. I don't think so. Maybe to follow now. Because
So let me write it in my sound machine.
Oh, wow.
right? Close it. Yeah. Yes. Of course, the sample right don't have. I don't see any diagrams like the sequence diagram. That one's the hope.
Oh man, I didn't know about this. Yes. I didn't know about this because I can find the sample of this document.
This one is not workflow. This one is just
What radar structure?
yeah, work without structure. Yeah. Like individual like user. But not a display.
Can send you
Once you
sample.
have the user story, you can dark type break down it.
Can send you sample. So I can tell my
Okay, again, this one is you actually set your source IP. You set a source
Can I
IP,
send it to
NIO6. Destination IP, NIO5, which is your host ANP. Then you actually put like you actually put a IP, because IP is actually a load. Then you put a ICMP on top. Then you send it. Alright, then you send it.
You're doing exactly the full record.
Yeah.
Yes, that's fine.
Hey, wait, the sample got wireframe or not?
Better.
Right.
Yeah, full record. I mean, the AMP is so just
Yeah.
if you really do a sequence, you can just cut out. You can use it for your actual report.
How do you test this one? You run it in your attacker container. You use Wireshark. You will not see anything from your host A and host B, because you basically send out using the attacker container. So there's no response from host A or host B. But in Wireshark, when you scan, you should be able to see that your IP address, right, the source IP address is 10906.
Not even one word.
Instead of the real IP address of your attacker container. Alright.
You can do it.
So let me just try it out. Again, I copy the volume. I copy the volume. I turn on my Wi-Fi. start the VR adapter. CD to the modules folder right in my vector. Right, notice that in my Forte and Holy containers were just nothing. Which is correct because you are not actually sending anything from the host A or host B, you're sending it from the attacker container. You go to Wireshark, you'll be able to see that as a string request. Right, look at the source address is 10906. Okay. Destination address is 10905. Alright, if you look carefully, alright, if you look carefully, the Ethernet, you look at the Ethernet, right, the source Ethernet is, the last byte is A2. It's not the actual machine which should be 06. Right, look at the MAC address. The MAC address is actually from your attacker container, alright? You can change it further example. You can change the source IP address to, let's say I use the Google Fabric DNS server 8. Right, like this number, very easy to remember. This was this still the Chinese period here. Lucky number. Save it. Our software use the Google DNS. My Wi-Fi is still steaming.
Record this. What's the last piece?
I run it. Go to my Wi-Fi. So you can see that now this is 8888. Alright. The source IP address is 88. So it's moving. But again, looks carefully, alright, the source MAC address is, the last byte is 82, which is actually your attacker container. So something that you can try. Because the 8888 is a line that we have a route all the way to outside the internet, so we are able to get a response text from the 8888. Sorry, we are able to sort of like respond back to that. The reply for this is you will actually go back to the software. Yeah. This one actually went back to the A2. The first one, the first one it actually goes straight because it's a local area. You actually go back to your host. Is the that means that it doesn't actually go through router because the first one is actually basically doing everything on the same network. So everything from the same network you'll be able to sort of like find that particular machine. If it is outside your network, you will need to go through sort of like a gateway to go offline. Then you will actually respond back. Rightfully, it should actually respond back to gateway.
Oh,
Second one, yeah, you actually go back to the straight away. Yeah, because I think,
I wasn't got phone.
let's see the ARP.
I got child, sister, then one more I think is the AI API as an item. The actor is the AI. As AI, I want to create a description so that I can produce it for the child to, I don't know, something. No, generative. And that's why the supervisor said like,
Oh, okay, sorry. Because this one is because you send up from the attacker MAC address. You send up from the attacker MAC address, then the response, the target machine will have a ARP message to sort of like to map your this address to your MAC address.
we need to discuss it with the first version. Yeah, the first time AI sector.
So because it's outside, AAA is not on the same network. It's outside, you're sort of like connecting to this, to the 10901. And the attacker container, actually you have the 10901, which is actually the same as the EM002. This part is a little confusing because the attacker container actually uses correct the same IP address as your EM002. Okay, so it actually has the IP address as 10901. So that I think actually sort of like you look at the 10901 here. It's sort of like act as the routers also, right? The 10901. So it's here. So whatever outside traffic you actually send to here, the CA2 is the MAC address of this container. Yeah, it's a little confusing because of the users of the host. The config is actually using the host, which is actually having the same IP address as your EM002. So, but if you just use like the MAC address inside the
I think maybe you're the one that submitted for us.
Not much. Not that.
Yeah, because I was really using it all the time.
This is document control. And we haven't really updated.
Okay, use your sort of like the internal IP address, right? You'll be able to get back the, but if it doesn't find the ARP address, then this thing will not be able to get a reply. The ARP part. So if you do 10906,
Just in case.
when I run,
February.
I will be able to get a request and reply. But if I go to change further, I change it to the source is 10909. I will be able to send up, but I do not get a reply. Or I can send one packet. But oh, I can't even send. So, oh, okay, 109,099. Okay, I haven't copied yet, sorry. My mistake.
Wait, no, here is
Send already, right?
no, I thought wait.
Okay, I should be able to send, so this was the ping request. But because my ARP cannot find the MAC address of 109,099, so I will not be able to get back from ping reply. Yeah, you want to find out the case which is related to that user ARP number. So you can send, but because the corresponding MAC address is not found, you'll not be able to get a reply. The ARP number. So this is your MAC 1.2.
When I suppose see our user story like instead of your computer. Say, which of you guys got for you user story, SSD story, skill description. Then we like, I don't know.
1.3 is actually pretty interesting. This one is for you to review, right, the SCP to estimate the distance. So in terms of your numbers on the route, so I guess you probably use the trace route command before, or trace cert or trace cert, depending on whether you run it in your Windows or Windows or your machine.
I don't know. Probably.
So you're going to write your own queue. You can actually set a packet. TTL value is set to 1. So the packet will be dropped. So they'll send you your ICSP echo message to increase it to TTL value 2. Then it will be dropped by the second router, which is TTL value of 3. It will be dropped by the third router, and so on. Until it actually reaches the destination.
This literally was escalated.
There's actually something like that. TTL is your calculator.
I mean, I did put first screen.
Well, let's say this is the machine state, like you have a laptop. You have a server hierarchy. This is your connected to a router, not all the switches. You have a router 1. You are router 2.
I just
You are router 3. Then you reach the final destination. So if you send the TTL value of 1, okay, it will sort of like actually give you back the router 1, because when you actually have TTL value 1, every router it will sort of like every router it will like drop by 1. Alright? Drop by 1. So it will actually send you back ICMP
probably like 1 day everything is like
error, like some kind of error. Then you send TTL value of 2, then you change it to 2, right? Router 1 is going to drop it to 1. Then you get an ICMP error back from router 2. Press like this. Then you will send 3, right? Then router 1 will drop it to 2. Later you can actually see it from the Wireshark. Router 2 will actually drop it to 1. If you reaches your router 3, you will drop it. So you, when you actually send the ICMP error, you'll be able to find the IP address of that particular router. Then when you actually use the TTL value of 4, you'll be able to reach the beat. Right, so if you use for yeah, it's something like counter. So every time you pass one router, the router will drop it by one. You'll be able to send a IC and echo right. Right, then you'll be able to find the IP address. So the tracer and trace route command, in fact, they are actually sending out a series of ICMP echo requests. Then it keeps increasing the TTL values until it actually reaches the destination. So it actually gives you a whole list of like IP addresses.
Yeah, no idea. Because like, when I asked my supervisor,
Yes, calculating the number of your routers, the number of routes that you can actually reach to the line. Generally, the more router you go through, the longer the latency. It may not be like directly sort of like proportional, because it depends on the router distance and so on. But it gives you a gauge. The more routers that you go through, usually is the latency is actually longer.
can I change the thing?
So you can like increase, right, increasing the TTL value, then you can actually find the IP address. You can actually just run like manually run them. Then you will actually get the address. Right, and sometimes I run the tracer command. It's more like that. Basically, I run the tracer command in my Windows. Right, actually not the tab. It's not the tab. It's just to show us the tracer command. You notice that some of these are not able to get IP address. It's possibly too long, right? You get what it comes out. Or the router may not sort of like respond, right? ICMP packet. Right, some of the routers on the internet they block it and things like that. So it's not a need, alright, for the Google's DNS routers, right? It's actually like 11 routes that actually reaches it. Just a piece of code that you can run. Let me just run it to see whether it works. If it works, I will put it in the bullet. Probably faster for you to try out. start the Wireshark.
Tiger is so useless. Tiger is so useless.
Well, sometimes they actually do go through different routes. So if I compare with like what my machine, which is actually running directly, alright, from my host machine, it actually started with 10.41641. So it's actually the second route in the VM. But VM actually takes one more route, 10.041. Then the second one is the same, alright, third one is the same, fourth one is the same, then it has request timeout and no response. This one is the same, then request timeout. This is the same. Alright, then there's one more route here, there's no reply and reach the target. So more or less the same, right? More or less the same. So this worked. If you look at the Wireshark code, okay, I possibly captured the wrong interface, right? I shouldn't be capturing the BI interface. Right.
But I think that's only for like tracking.
Right, let's try the EMP0S3.
Sick, yeah.
Not that maybe use the N.
You can just take a Gantt chart, right?
Oh,
You
yeah.
can just use Gantt chart.
Okay, so if you look at the Wireshark trace file, you'll see a lot of like TTL exceeded. You scroll down and look at it, it actually tells you things like echo request, and if you open out the IP, it actually has like a TTL, this is actually a response. But if you look at the previous packets, the ping request, you see ping is actually 1. Then ping increased to 2, 3, then 4, 5, 6, and so on. Alright, on this packet. Let me just put this code. Or you can actually ask the AI to come out this code. Some of the codes you can actually use the AI to generate. Some of the codes you may not be able to generate directly.
This one is from the first slide. First lecture slide.
For your convenience, let me just put this in the folder.
Other requirements.
I call this
Project
let
scheduling Gantt chart.
task 3, right? Task 1.3, right? Task 1.3.txt. If I send a TXT file, right, just copy the content and just use it in your computer. Right, so this is actually the trace,
Or some user stories.
the trace route, the start trace route. Or you can actually use one by one, you just increase 1, 2, 3, 4, 5, and so on. You don't have to use the 8.8.8.8.
This one.
You can actually use
I think the
whatever
diagram stop
outside IP address that you want.
sequence, then we do the
So in general, if you look at this piece
Use
of
case.
code,
use case as
this part is actually the substitution, right? Whichever IP address that you want.
I think that's enough for this.
This is the function that you have written, the trace route, so it's actually here. So you set a TTL equal to 1 first. You do a while loop, right? You do a while loop. Then you put your destination equal to the target, which is here. TTL equal to your TTL value. And you run this SR1 function. Right, this function will give you sort of like a reply. Okay, a reply. The packet is here. Details you can look at CAP documentation. If there's no reply, you just print out no reply. If the part equal to 0, if the part equal to 0, which is ICMP echo reply, you will print out the source IP address.
Virtual very ugly.
It's like if you go to Wireshark, if you see a reply which is the ICMP, not this one. Okay, sorry. If you have the path equal to 0, is the final one. It's actually the final one. It's actually the if you actually reaches your phase, then you will have an ICMP echo reply. Alright, if not, then you just print out the intermediate, right? The intermediate source address. So the intermediate source address will actually all the intermediate counters like R1, R2, and R3 in the state.
It's
Then of course the CPI is the counter and
the
that's
system. This one is the green is the one that
Yeah,
we
and
sent.
if I put it close, then you
So
will.
try
The green
out.
is the one that we
But the
sent.
code is actually in
But
the
this one like is the system.
folder. To do this experiment, right, you open up your Wireshark
Frame.
in your C machine drive, you
This one is
capture
the real setting voice. This one is what we do.
you capture this EMP0S3, not the VI. The VI is the Docker. So you capture this because the traffic is going outside. But still you capture the EMP0S, 0S3. Then you'll see a number of times to be executed per second. Which is correct. If you run a normal tracer and you capture it, it's also the same, right? You see a series of times to be executed.
Oh shit, cancel. I'm doing not touch. It will disappear.
So I'll stop one before I go to the last one, which is a more interesting thing for your future. Right, it's suppose.
And this should be quite simple now. Maybe 3 days can do it.
Right, this one basically is just doing the tracer or trace route ability.
I mean, wireframe, project schedule, get chart. I don't know what's that now. Huh? I think most of it is done. They just left with wireframe. Roles and responsibility get chart. Maybe the PA books or I don't know. Should be quite simple. But I think 368 the assignment not that difficult. Just copy and paste from the lectures like. Legit what? Like legit I just copy and paste. They ask you to use 15 protocols and some of the course. And then you state the layers. And then you put reference, that's it.
Yes.
Simple, right? Simple, right?
Simple.
Just copy and paste.
Simple, just copy paste.
Okay.
Find the thing in the lecture slide.
Like that's 2 hours finish got the lesson.
Okay, then I just go off the button.
I think I never see that. Anyway, the content is almost the same. You can just copy those points. You just have to use the table I will have someone to help me just simply just rearrange the table or the text. Because you think about it, right? The assignment is fixed one. There's not much change. You will see the assignment one, the requirement. Maybe just ask you for the lecture slide.
How your leg?
I put back my ankle guard again.
Ankle guard. Then your shoe how?
Not my shoe.
Then how you wear shoe from school? How you wear shoe from school?
Yeah? Okay.
Where the guard there?
Huh? I never put.
Oh,
You have to go back later.
It's only Wi-Fi network.
It's really stuck
super interface.
还没有本事做。
Ah, super interface. Super interface.
Protocol is protocol. Schedule lecture one to start. Context is Wi-Fi, free Wi-Fi and fast connection. 7.
Donation again.
Yeah, for 7 fine.
Alright, then the last task is actually Steam and School.
Lower the website HTTP.
So you will combine the Steam and School
And your
to,
Wi-Fi.
to do this program. So you need 2 machines.
Login.
One is actually your VM, the C,
How do you login? How do you
and the other is the user container.
Very fun.
So user container will ping whatever IP address
And this one
is the
reference
X is the right,
what is like
right? In program receive echo reply.
no P or S.
So your program that run on the VM, the CPM, you will monitor the back. It's actually receiving all the packets and monitoring.
guest profile?
When you see an ICMP echo request, you will send out an ICMP echo reply. Okay, using the packet selection technique. So whether the machine X is alive or not, the big program will always receive a reply that tells you that X is alive. Okay, so you use CMP to do this task. Okay, you actually don't need any report or things like that. Okay, remember, for the deck, there's nothing for you to study. Right, you don't need, the deck is actually for you to experiment.
I don't know about break.
So in your experiment, you should pick 3 IP addresses.
Install the VM.
Alright, you need to understand a little bit on the ARP protocol, so we have actually discussed more on last lab, which is lab 2.
You know what? Wow. I need to reset. Back to factors.
Can you try closing and opening?
Let's play a part.
No, I already tried. It doesn't work. Only black screen.
No using of rate. Pause it means. Angle.
So I need to reset the page.
It's a color table.
Okay, you can actually use container 10945 to try out the, for it to try out.
Increasing the remote rate. And the
Right, so this code basically just do the sneak, right? It actually uses the sneak function. again you have to change your iframe, right? Just like filter is ICMP. Or you just look at ICMP file. You actually run this function, right? Like example for this case. If your ICMP in the right in your packet, then your part equal to 8. 8 is ICMP echo request.
It's gonna be more. So that's why we
So you'll get a reply. So the basically is actually just like, right? You sort your source and destination IP address. So the source becomes the destination becomes your source. Right? Destination becomes your source. The source becomes your destination. Okay. Then you set an ICMP, the part equal to 0. Part equal to 0 is the ICMP echo request. Alright. Okay. The ID and sequence, it actually uses back the original ID and sequence. Then it actually put the IP, ICMP, and the raw packet, right? The raw packet for this thing, and load it, and send out the reply. And here actually just have a message to reply back the spoof packet to this particular part, the source, right? The original source. Alright, again, this part, let me just save it and actually send it to you, or see it easier, right? I put it in the folder. Alright, you can actually use the container 10.0.5. Then you test it, alright, you can actually test it. Okay, so this is a text file also. Alright, I put it as lab3 task1.4.txt file. Alright, the first part is actually the code. The first part is the code. The second part is actually the response. You can test it. So let me just run this part. Copy this code. Remember, you have to change the VR to the one that you have. If not, you will not get a result. Try the VR. Copy. Okay, that's good. I can actually either run it in my sort of like hacker machine, so I can actually follow. I don't need to copy, so I can follow the lag guide. The lag guide asks you to run your Steam and spoof programs on the VM on the SIG Ubuntu directly. That will be easier. I mean, it's the same, but I save one step to copy over to the container. Remember, if you run it in your container, then you've got a sudo insert. Alright, run a sudo command. Then I can actually follow the testing. Alright, I can actually ping 1, 2, 3, 4. But before that, remember to turn on your Wireshark. Go back to sniff the PR, alright, the PI interface. It's the PI interface. From the container log file, well, use SC1 for simplicity so that you only have one quick packet. You see that every time you send, you have received, right? One receive. Then it says send reply smooth packet in my own file. And go to my Wireshark. I have an echo ping request and an echo ping reply here. Right, ping request to 1, 2, 3, 4. Ping reply back from 1, 2, 3, 4. 1, 2, 3, 4 is a non-existent IP address on the internet, so that the machine is not alive. That's the whole purpose for this lecture. So whatever things you think about this, you see like this. You have your EM Ubuntu. You run your program here. You write your Python code here. So you have your 10.9.05 here for experiments. Whatever things that it actually pings, it pings whether the machine is, let's say this machine is alive. This machine will reply and your program will reply. Okay? Let's say this is not. Right, not alive. You think something like not alive. Right, this machine wouldn't respond, but your Python program will respond. So rightfully, whatever that is responding alive, you will get 2 ICMP echo reply. One from the actual machine, one from your program. Whatever that is not alive, you will get 1 ICMP echo reply from your Python program. Alright, so this is the interesting part. So the machine, whichever things that it pings, is not alive. Which is actually by your program. Okay. So you might think 1, 2, 3, 4, because 1, 2, 3, 4 I cannot reach it. You will send back a reply. But this reply is actually by my Python program. You might go to ping another 10999. 10999 is a non-existing host on the net. I will not see any echo reply. Right. Let's look at why that's so. Let's try out first. I get a 0 receive. No response. From here, I cannot see any 10909. Why? It's because of the ARP. The ARP is sending out an ARP request to say that who has 10909, who has actually 10999. No response. Right, that's no response. Because it's the text. It's not existent. Right, so 10999 has no response. If I try 8888, I will have 2 echo replies. I will see one packet transmitted, one received. Then your program will send one packet reply, one spoof, right? Packet to send level 5. You go to Wireshark to see. I send out one echo request, but I get back 2 replies. Right, I get 2 replies. One is actually from the actual Google DNS server, one is from my program. Or you look at the MAC address, you can't tell the source and destination MAC address because both actually come from the last byte, the A2. It's because of the way that the Docker is set up. You can't tell. It's an external address, external. If you go to ping 10.9.06, right, it's an existing host on the plan. Right, you will see 2 echo replies. Again, I get 1 transmitted, 1 received. I cannot do it here. You see, I send 1 request. I got 2 replies. Alright. This one you can see. One of it is actually from the actual machine CNI06, right? You look at the MAC address, 06. One of it is actually from my program. So the source MAC address will be different. Alright, so this is the code that you can actually try out, which I think is an interesting code. Alright, if you run it in your home network, then everywhere you think you'll get a response. Okay. I will not move on with the let task set 2. I will possibly put some code in like your task 2.1 and those that are interested, you can actually try it out. Alright, then you just put some instructions. I will not post everything. You possibly want to try your Right, we need a task 2.1d. Alright, post a task 2.1d. Let's try it out. 2.1c, if you try to steal it this way, you will be confused because of the way that Telnet actually uses it. You will get one character by one character. So that's a little bit just to see it. Right, for the packet, so you'll see like S, then you'll see E, then E, D, and things like that. Really difficult to see. So if you want to try things like right, spoof, sneak and spoof, right? Just actually the same thing, right? Just actually the same thing as what you have done in the Python. Right, so possibly I will put this with you. Alright.
Yeah.
So I will stop here, right? I'll stop here. I guess some maybe have some questions. So I will be here. But anything, let me know. Right? If you hit problems, you can let me know. I try to like have a troubleshoot.
Yes.
So tomorrow one we'll be going through is your lab 4. Lab 4 will be shorter, so we should have actually more time, right, to discuss
Oh yeah, the special
more
character.
details, right, on that. This is actually ICMP redirect. Right, so but although it's shorter, the next one is actually more complicated for that one. You have to look at that. Right, so this is that one. So if you can, right, if you can, you may want to read beforehand on this part, that environment. You need to Docker compose down, then Docker compose up, copy the that for that setup. It doesn't have two parts, so we are not, we are only looking at two tasks. Okay, so I will be here. Anything just let me know.
Okay, fine. You look for you only. Oh yeah, the class already end. End already. Then I just stay here. This one is the country betting. Sorry. Because this one is like
It sounds like I put the tongue to
I think we need. Sorry? What? What? Yes.
Three years. Then also from you. No lah.
Really?
No lah.
Actually, this really is this